Here we have another limits at infinity example problem. And in this example problem, we're going to have a function that is going to include some exponential functions. So you can see here we have some e to the x's throughout our function. And so before we get into this example problem, we know that for the limit as x approaches infinity, which is what our example problem is, e to the positive x is going to equal infinity, whereas e to the negative x is going to equal 0. So we want to keep these two things in mind when we solve this example problem. So we'll go ahead and get into it. And the first step is we want to focus on the denominator of this example problem and try to get rid of as many infinity results as we can. So you can see that we have some positive exponents in the first and second term, but we have a negative exponent in the third term. And so what we want to do is we want to simplify this denominator in order to have negative exponents throughout the terms, so that way they can reduce to 0. So we can go ahead and see that, like I said earlier, our first and second term will produce an infinity value, which is not good, whereas our third term will produce a 0 value when evaluating the limit at x approaches infinity. So what we can do is we'll factor out this x to the 4x term. That way our first term will just be a constant. Our second term will have that negative exponent, and our third term will still have that negative exponent. So now that we have our denominator simplified, we can go ahead and solve this example problem. So this is what we started with. So now we'll factor out e to the 4x from the numerator as well as e to the 4x from the denominator. And so we can go ahead and evaluate the limit as x approaches infinity. And you'll see we'll get 6 minus 0 in the numerator. And in our denominator, we'll get 8 minus 0 plus 0, which we can simplify to be 3/4 for our solution.